I'm sitting here with Michael Sperber. Welcome, Michael, at the architecture gathering in Munich. And Michael, would you like to introduce yourself?
Sure. So I'm CEO of a company called Active Group in southern Germany. We do mostly software project development for our clients, and I guess the special thing that we do is we do all of that using functional programming. We do a little bit of training on the side, but mostly we actually just write software.
Okay, so why would I care about functional programming? I mean, I did have some courses on functional programming at university, but that's rather academic, so why would I care?
So our experience has been that functional programming just improves all aspects of programming and of software development. So at the lower level, functional programming is about immutable data mostly. And that means that you don't change your data. And changing data, data that changes underneath your program as it runs, is one of the major causes of problems as you sort of do the lower levels of programming. And as you move up higher, the benefits that you get from that just increase, because at an architectural level, if you have side effects anywhere in your program, they always complicate the interactions between the parts of your program, and that means that using functional programming reduces coupling and gives you all of those other benefits that you want from good software architecture.
Yeah, but at the end of the day, I mean, software is all about changing data. So why would I have only immutable data?
Yeah, good point, right? You write software and you want to run software to change the world around you. So that might seem like a paradox, but what we do, so that still doesn't mean that all of your program needs to be about changing data, right? I mean, essentially, if you have a large system, lots of parts of your system can be described in terms of functions, how you transform data, how you turn this into that, and the effects are only something that you want to have at the boundary between your software and the world, and that's typically how you do software architecture in a large project. When you do functional programming, is you push all the side effects to the boundaries of your system with the outside world or with other systems, and you keep as much as possible of the inside as pure as you can. I mean, functional programming doesn't necessarily mean that everything is pure and everything is immutable, just that you try to do as well as you can, keeping things unchanged.
So obviously you do a lot of your business or all of your business using functional programming. However, outside your company, functional programming is probably something that is mostly relevant at universities. So how do you feel about whether this is really something that people do in practice?
Yeah, well, that's a very German perspective, right, that it would be an academic discipline. So for a long time, I've been involved, or I was involved in the research community on functional programming, and many years ago in the 90s, we started a yearly workshop on commercial users of functional programming. And I think in the mid-90s, it was sort of like a therapy group. Everybody patted each other's shoulders, and we were learning, you know, it's going to be big someday. But over the years, more and more people came to us from companies that reported about their projects doing functional programming. And actually, that workshop sunset 2 or 3 years ago because they felt that it had arrived in the mainstream. So I think everywhere, except in Germany, functional programming is just, well, it hasn't exactly gone mainstream, but a lot of companies use that very routinely. So large parts of Facebook's infrastructure are done using functional programming. Their tooling is almost all done using functional programming. Twitter's infrastructure, when they made the leap from Ruby on Rails, was done using functional programming. And of course, there's lots of startups that also use functional programming, because one of the other benefits you get from it is not just that you get better software architecture, but that your productivity increases. So if you want something done quickly in some sense, then also functional programming helps with that. So there's a lot of companies that use functional programming. A lot of them you maybe don't know about it. A lot of banks, for example, do that, and you don't really hear about what they do. It's just a German phenomenon. I think that we're a little bit more conservative adopting new technologies.
Okay, I see. So you already said that concerning the architecture, you end up with a functional core, and then the stuff that does side effects is pushed to the boundaries. We are sitting at the architecture gathering, so there are a lot of architects around here. Is there anything else that is relevant for an architect concerning functional programming?
Yeah, absolutely. So I would say the other major aspect that is different in functional programming is the modeling aspect, and I'll give a talk about that later, in that we use So typically what we do is we build models that are based on combinators. I think that's a concept that you can also do in object-oriented programming, where you try to restrict the number of entity kinds that you have, and you just build things that build larger things from smaller things. And that typically gets you more flexible models than you get from traditional object-oriented models. Also, what we do in functional programming is, so functional programming languages give you more abstraction capabilities, so we tend to build more abstract models and then sort of specialize them to a concrete domain. And also when we're in a domain and we build a domain model, we tend to look for abstractions. And functional programming particularly enables you to use abstractions that come from mathematics, and that might be unpopular with some developers who feel that they don't like mathematics. But on the other hand, I always thought that, well, humanity developed mathematics to do formal domain modeling. That's what it was originally developed for, and it would be foolish to throw that out the window when it comes to software development.
So you did part of the FunR architecture training, the concept for that has been standardized in the iSAQB. Can you say a few words about that training, what it is, why I would participate in it?
Well, as I said, right, so functional architecture is very fundamentally different, and it has benefits. So I think architects benefit from knowing about functional architecture, and that's why we did that curriculum, so that you could get those benefits. As you also pointed out, it is a niche, and a lot of people come to functional programming not knowing about it beforehand. And so really the curriculum tries to straddle the divide between traditional software architecture and functional programming. And that divide actually exists on both sides, as we found out. So a lot of software architects don't know about the specific aspects of functional software architecture, and a lot of functional programmers don't know about building large-scale systems, right? They keep that knowledge at the places that they work at, and researchers have mostly been concerned with programming in the small. And so the curriculum tries to do an introduction to functional architectural concepts for sort of traditional software architects coming from the foundation level training in iSAQB.
Would I need to know a functional programming language to join that training?
No, not at all. There's a first day that has an introduction to functional programming concepts. Also, the actual trainings that do happen typically do an optional prequel course. That's just a one-day course in front of the actual training that provides a more basic introduction to functional programming.
Okay, thanks a lot.
Thank you.
Thanks.